Source: Xinhua 20171228051427. Editor: Lu. Video player. Close. Photo taken on December 30, 2016 shows Chinese telescope AST-32. Chinese scientists on Monday announced observation of the optical counterpart of gravitational waves coming from the merger of two binary neutron stars using a survey telescope in Antarctica. The gravitational waves were first discovered by the U.S.-based Laser Interferometer Gravitational Wave Observatory LIGO detectors on August 17. The Chinese telescope independently observed optical signals resulting from the merger the next day, according to the Chinese Center for Antarctic Astronomy. It was the first time humans have detected gravitational waves and the corresponding electromagnetic phenomena resulting from a binary neutron star merger. Xinhua Chinese Center for Antarctic Astronomy, Washington, Dec. 27. Xinhua. From gravitational wave seen in neutron star collision to life-saving gene therapy, the year of 2017 has seen major science breakthroughs, trends and events that will potentially shape the future of human life. Following 10 science events, which have major impact on the world in 2017, and for many years to come. Gravitational waves usher in new era for astronomy. On August 17, scientists detected gravitational waves, the ripples in space and time, and light from the collision of two neutron stars. It was the first time a cosmic event has been seen from Earth in both gravitational waves and in light. In other words, the event helps to bring together traditional light-based astronomy with gravitational wave astronomy for the first time. I think this is a really major discovery in the history of astronomy, David Reitze, executive director of U.S.-based Laser Interferometer Gravitational Wave Observatory LIGO, told Xinhua in an interview shortly after he announced the discovery. Gravitational waves were originally predicted in the early 20th century by Albert Einstein, but they were only detected for the first time by LIGO in 2015, a discovery that was awarded the Nobel Prize in Physics this year. Life-saving gene therapy with hefty price tags. Decades of research on gene therapy is finally paying off. The U.S. Food and Drug Administration (FDA) approved not one but 3 life-saving gene therapy products this year. The first, called Kymriah, was approved in August for certain pediatric and young adult patients with a form of acute lymphoblastic leukemia. Kymriah, known as a living drug, uses a patient's own immune system cells, called T cells, after these cells have been modified to better recognize and kill the patient's cancer. The one-time drug is now priced at $475,000. 2 months later, the U.S. FDA endorsed Yescarta, a similar gene therapy, to treat adult patients with certain types of large B-cell lymphoma. The initial list price of Yescarta, also a one-time treatment, is similarly expensive at $373,000. Then in December, the regulator green-lighted a gene therapy called Luxturna to treat patients with a rare inherited form of vision loss that may result in blindness. The treatment delivers a normal copy of the mutated gene directly to retinal cells, leading them to produce a key protein that converts light to an electrical signal in the retina to restore patients' vision loss. Luxturna reportedly has a possible price tag of as high as $1 million. I believe gene therapy will become a mainstay in treating, and maybe curing, many of our most devastating and intractable illnesses, FDA Commissioner Scott Gottlieb said in announcing the approval of Luxturna. We're at a turning point when it comes to this novel form of therapy. CRISPR gene editing speeds into clinic amid ethics debate. The revolutionary gene editing technology CRISPR is moving rapidly into the clinic, with a report from the U.S. National Academies of Sciences, Engineering and Medicine recommending in February that clinical trials for gene editing of a human embryo could be permitted in the future, but only for serious conditions under stringent oversight. This year, scientists using the 5-viral tool have made advances in fighting diseases, antibiotic-resistant bacteria, mosquitoes and much more. For example, researchers from the Temple University made the first successful attempt to use CRISPR to remove HIV from a living organism. In August, a team at the Oregon Health and Science University reported the first known attempt at creating genetically modified human embryos in the United States. Meanwhile, major improvements have been made in the technology itself. The newly developed systems are now able to target the smallest units of our DNA or RNA, and Chinese researchers demonstrated the power of the so-called base editing by fixing a disease-causing point mutation in human embryos. Scientists have also made breakthroughs in their quests for solutions for the worldwide shortage of transplant organs. In January, U.S. researchers announced they have used CRISPR to successfully create the first human pig chimera embryos, bringing us a step closer to growing human organs inside pigs. In August, researchers from the US, China and Denmark reported that they have edited the pig genome to deactivate a family of retroviruses in order to create piglets that can pass the viruses on to transplant recipients. Bright future for quantum communications. Quantum supremacy. The past year has also seen a series of major advancements in quantum communications, which are currently described as unable. In June, Chinese researchers announced that they had transmitted pairs of entangled photons from the MISHAS satellite to two ground stations located more than 1,200 kilometers apart. Previous efforts to entangle quantum particles, such as photons, have been limited to about 100 kilometers. The experiment shows that long-range quantum communication is indeed technologically feasible and holds out the promise of the construction of long-range quantum communication networks in the near future. Seth Lloyd, director of the Center for Extreme Quantum Information Theory at the Massachusetts Institute of Technology, told Xinhua at that time. In August, China inaugurated the world's first line of quantum communications between the cities of Beijing and Shanghai, which covers a total length of over 2,000 kilometers. We hope to form a ground and space integrated quantum communications network in about 10 years, and apply it widely in fields such as national defense, government affairs, finance and energy, Pan Jarvai, lead scientist of the MISHAS project, said earlier this year. Meanwhile, Google, IBM and several other tech giants are now in a seemingly tight race for quantum supremacy, a state which allows quantum computers to beat even the strongest supercomputers. In November, IBM announced that it has successfully developed and tested an operational prototype processor that handles 50 qubits, which are believed able to exhibit what's known as quantum supremacy. Google was reportedly to unveil a 49-qubit device soon. Intel is also betting on a quantum-enabled future, with the revelation of a 17-qubit processor in October. There are also many other groups around the world pursuing different approaches to achieve the supremacy. It's obvious that there's now a worldwide race to build quantum computers able to do things that are classically hard. Professor Scott Aaronson, director of the Quantum Information Center at the University of Texas at Austin, explained to Xinhua. "I'm just excited that it looks like someone will win this race within the next year or so." Astronauts set to go back to Moon in July of 1969, the U.S. space agency NASA succeeded in sending astronauts to the Moon. About half a century later, U.S. President Donald Trump instructed NASA to do so again, with an alleged goal of laying a foundation there for an eventual mission to Mars. The Trump administration has not yet laid out a detailed plan for returning Americans to the lunar surface, but NASA is exploring a concept of building a small space station around the Moon known as Deep Space Gateway that would serve as a waypoint to the lunar surface and deep space. China, the third country which has independently sent humans into space, is also working on an idea for manned lunar landing. According to Wu Yancheng, general manager of China Aerospace Science and Technology Corporation (CASC), the mission will consist of a manned spaceship, a propulsion vehicle and a lunar lander. The manned spaceship and the lunar lander will be sent into circumlunar orbit separately. Yang Liwei, deputy director of the China Manned Space Engineering Office, said that China is in the preliminary stage of its manned lunar program and estimated that Chinese astronauts will be able to walk on the Moon around 2030. Artificial intelligence comes out of lab. Artificial intelligence AI is not only challenging and defeating human players in the ancient Chinese board game Go, it's also predicted to penetrate and even transform industries from manufacturing and transportation to finance and healthcare. And scientists scouring data from NASA's Kepler Space Telescope even used AI to discover an eighth planet around a star 2,545 light-years away this year, making the distant solar system the only one besides our own that has 8 planets orbiting a single star. By 2025, annual worldwide AI revenue will grow to $89.8 billion, according to Tractica, a U.S. market intelligence firm, an increase from only $3.2 billion in 2016. I think AI industry is now in its infancy, and what we are seeing is just the tip of the iceberg, Zhang Yaqin, president of China's tech giant Baidu, told Xinhua earlier this year. The impact of AI on human beings would surpass that of the steam engine, electricity and the internet. It will open up a new era and transform business, lifestyle and society. U.S. withdraws from Paris Agreement on climate change. Climate change has become a global challenge that requires action from all countries across the world. But to the regret of almost all, Trump administration announced in June that his country would withdraw from the Paris Agreement on climate change, which is regarded by many as the best chance we have to save the planet. All nations must cut their emissions sooner and deeper than called for in the Paris Agreement for the world to have any realistic chance of limiting global warming to no more than 2 degrees Celsius. John Sterman, professor at the Sloan School of Management of the Massachusetts Institute of Technology, told Xinhua at that time in responding to the withdrawal. U.S. withdrawal makes the greater ambition needed to avoid the worst risks of climate change more difficult. The Paris Agreement, agreed on by almost every country in the world in 2015, aims to tackle climate change by cutting greenhouse gas emissions and sets a global target of keeping the average temperature rise no higher than 2 degrees Celsius above pre-industrial levels. In the face of the U.S. change of heart over the landmark deal, other major players including the European Union, China and India have reiterated their willingness to step up efforts to tackle the climate change. New cancer drug defeats multiple tumors. In May, the U.S. FDA granted accelerated approval to a treatment for patients whose cancers have a specific genetic feature. This is the first time the agency has approved a cancer treatment based on its DNA rather than the location in the body where the tumor originated. The drug, called Keytruda, which has previously been approved to treat metastatic melanoma and a handful of other tumor types, can now be prescribed for any advanced solid tumor that carry a common genetic defect referred to as microsatellite instability higher mismatch repair deficient. This is an important first for the cancer community, said Richard Pazdur, acting director of the Office of Hematology and Oncology Products in the FDA's Center for Drug Evaluation and Research and director of the FDA's Oncology Center of Excellence. Until now, the FDA has approved cancer treatments based on where in the body the cancer started, for example, lung or breast cancers. We have now approved a drug based on a tumor's biomarker without regard to the tumor's original location, Pazdur said. First GeneticalModified animal hits shelves in Canada. AquaBounty Technologies, a U.S.-based biotechnology company, announced in August that it has sold approximately 5 tons of fresh genetically modified GM salmon fillets at market price to unnamed customers in Canada. Our salmon is only approved for production, sale and consumption in the United States and Canada, Dave Conley, a company spokesman, told Xinhua at that time. It will not be sold in China until it is approved by your national biotechnology regulatory authority. This is an important step for the company and for the technology as a whole, William Muir, genetics professor at the Purdue University, commented in an email to Xinhua. This will be the first GM animal approved for human consumption, and now the next step is consumer acceptance. I see no scientific reason to be concerned about the sale or consumption of AquaBounty GM salmon. 7EARTHSIZDEXOPLANETS discovered around nearby star. NASA announced on Feb. 22 that a compact analog of our inner solar system about 40 light-years away from the Earth has been discovered. The discovery gives us a hint that finding a second Earth is not just a matter of if but when, Thomas Zurbuchen, Associate Administrator of the Science Mission Directorate, said. An international team of astronomers using powerful space telescopes and ground-based observatories have discovered the first known system of actually 7 Earth-sized planets orbiting the nearby TRAPPIST-1, which is relatively close to us, in the constellation Aquarius. And 3 of these planets are firmly located in the habitable zone, the area around the parent star where a rocky planet is most likely to have liquid water. The discovery sets a new record for greatest number of habitable zone planets found around a single star outside our solar system, according to NASA.